Let's take a look now at example number 2. We'll see this is very similar and actually a bit easier than example number 1. I want to show that there is a root, or more specifically, I guess, a solution to this equation. Oh gosh. Now you could spend a lot of time here trying to find out what the solution is, but notice that's not what the question asked. The question said, convince me that there is a solution. It didn't say, show me a solution. It said, convince me that there is one. Show that there is a solution to the equation. So here's what I'm going to do. I'm going to go ahead and think about this kind of in the following way. Doesn't this almost look like I have a function right here, and I'm interested if that function could ever be equal to this y value? So let me go ahead and try to write out my work carefully. I'll say we will let f of x be equal to 4x to the third minus 6x squared plus 3x minus 2. Okay, we want to know if this function ever hits the y value of 0. Let's see if it does. We'll use intermediate value theorem, and I'll start considering what's going to happen over here in the picture. Okay, so let's see. I'm going to need to have a couple different things be true here. I'm going to first need my function to be continuous. Is my function a continuous function? Well, yeah, it should be because it's a polynomial. So I'll start off by saying we note that f of x is continuous everywhere because it is a polynomial. That's great. So that's one part of the intermediate value theorem that's checked off. Now I just need to be able to find a dot above and a dot below the y value that I'm trying to hit. So right now, I'm trying to hit that value of 0. That's like my capital N. And let's see what we can come up with. We need a point that's going to get us something above and below. Ooh, notice this. We also could note that what would happen if I plug 0 in for x? That would make the function spit out -2, right? So that could be a point below. And now I need to pick any other value in the universe that could get me a value that's going to be above. Now, I don't know what values would work here. I mean, we could try a whole bunch of values. We could try 1, right? Let's see. That would be 4 minus 6 plus 3 minus 2. So that's 7. 7 minus 6 is 1. 1 minus 2 is -1. Ah, darn it. Okay, see, that value is not going to work, but that's okay. If that value doesn't work, let's just try a different value. How about a value like 2? Let's see, that's going to be 4 times 2 to the third minus 6 times 2 squared plus 3 times 2 minus 2. So let's see, it's 4 times 8 is 32. 6 times 4, that's 24, plus 6 minus 2. All right, let's see. This is going to be 32 minus 24 is 8. 8 plus 6 minus 2, that's, I don't know, what is that, 12? Hey, this works perfectly. So if I plug in 2, I get back a value of 12, like way up here. And since my function is continuous, I know that when I play connect the dots, I'm going to have to cross. Notice I might even cross more than one time. That's totally okay. That would just mean that there are multiple solutions. I don't know how I cross, but I know that I'm guaranteed that there is at least one time that I cross. So notice I can write my conclusion in the following way. We then know by the intermediate value theorem that there is a value c in the interval from 0 to 2, right? There's some value between 0 and 2 such that f of c is equal to 0. Now, I'm not quite done because the question didn't ask me if this function equals 0. It asked me, does this equation have a solution? So I'm going to make sure that we conclude with that, which now I can state. So 4x to the third minus 6x squared plus 3x minus 2 equals 0 has at least one solution. It might have more, but the intermediate value theorem has guaranteed me that there is one. What's kind of interesting here is that the intermediate value theorem never tells us what the value is for that solution. It just kind of tells us where it is. It shows us that it exists, not the actual value that it has.